our plug in there with our hose so that we can go ahead and put pressure to make the envelope. I'm just going to go ahead and seal the end off nice. We'll heat the glass up, put a little bit of pressure, and even out the end so that the end and the sides of the envelope are the same thickness. That way when we blow it, it doesn't have a thin spot. Now, for the type C valve, we need about a 2-inch diameter and 4-inch long envelope. So I'm going to go ahead and I'm going to stick this out a little bit more. And we're going to put about 4 inches of it. Two inches in diameter. We'll just start heating it up. I'm going to put pressure on it and just blow it out. Okay, we're getting a little wobble here, so I'm going to go ahead and use the carpet tool. I'm going to warm it up and just press against it to get the wobble out. Okay, we're right on center again. Okay, now that gives us our envelope. Okay, the next thing we have to do is we have to put a stem on the end of it to evacuate it. Okay, to hold the stem, we have it sealed off on the end. We put it in the Teflon holder, and that fits into the holder on the chuck of the leg. First thing we're going to do is blow a hole in the end of the tube, envelope. Just heat up a spot on the end and put pressure with the pressure hose, and that'll just blow a hole. Okay, that gives us a nice little hole there about the size of the stem. Now we're going to use the carbon tool. We're going to put a little flare on the end of that stem, and that makes it to where the stem will have less tendency to seal off. When you heat up any small tubing, it tends to close up due to surface tension. By putting a little flare on there, we compensate for that. So we just heat the tube up. press them together, pull them apart, and it's now sealed on there. Now I'm going to use pressure to even it out. Now, the bottom end of this is too large in diameter, so we're going to draw that out to take it down to about 1 inch in diameter for the flare. To do that, we clamp the stem, and then we'll pull back on this chuck. Okay, we now have the area we can heat. We'll heat the area, and then we'll draw down on it, and that'll pull the glass to decrease its diameter. See, as we pull it back, it's getting smaller in diameter. What I'm going to do is use the carbon tool, and I'm just going to push in on the tapered area here to make it all a uniform 1 inch in diameter. Okay? Okay, and that's our envelope. Okay, to cut the envelope off of the stem, we use the diamond saw. WD-40 is our lubricant. Just like that, it's off. Diamond saw is very effective at cutting the glass. Okay, and there's our envelope. It's a little bit rough, but you know, amateur glass blowing is not professional. It'll work fine. Okay, here we have our parts of the tube. Okay, this is a cutaway of the tube. We have the plate which fits over the glass stem. That's what holds the plate in place. That's a different way of doing it than in other tubes. Very questionable design there, but we're going to make it the same way as the original tube, so we'll go ahead and do that. Okay, the envelope, we have a 1 inch mouth on it where the flare itself will seal. That's going to be the main seal for the envelope. Now the plate and the grid are brought through side leads coming through the side of the envelope. That's another bad design that very difficult to do successfully, but we'll do it since that's the original design. Now the flare itself, we have to make the part that's the diameter of the plate. Our plate is just a piece of conduit. I took a piece of electrical conduit, 3/4 inch in diameter, and I cut it to the 2 inch length and then machined it to where it's about 15/1000 of an inch thick. And that's our plate. It's made out of steel. Okay, and then we'll use a piece of tubing that plate will fit right down over, and that's what will hold the plate in there. Now we're going to have a total of 6 wires coming through that are going to be used to support the grid. We'll weld those wires onto the bottom of the grid cage. The grid is made up of wires that are just soldered in, not soldered, but welded into a screen-like finger that goes over the filament. Now, there will be 3 wires in the pinch that are used to connect onto the grid. That will provide stability to keep the grid sticking straight up inside the plate. And it'll hold it concentric with the glass stem. Okay, then we have the filament. We're going to have 3 wires for the filament. The center wire will be a support wire that goes up to the top, and then we'll just make a hairpin of tungsten wire coated with oxide. That will be the filament, and that'll be about 1 3/4 inches long. Okay, so what we're going to do now is we're going to make this pinch right here. We're going to make the pinch and the flare. To do that, we're going to start off with tubing that's the size of the plate. Okay, we have a piece of tubing the size of the plate mounted in the chuck. Now, we're a little bit large in diameter to make our flare, not flare, but our pinch. So we're going to first draw this down to where it's about maybe a third smaller. To do that, we'll just we'll heat it up, and we'll use the carbon tool. Okay, that's going to be the piece where we make the pinch. So the plate itself will fit over it like that, and the pinch will be there, and the filament and the grid will be up inside. Now, we have our electrodes as they were made as in other videos. If you want to see how the electrodes are made, look at the one on making a spherical audion or the plumbing valve, and it shows how the electrodes are welded. We have them clamped in a piece of aluminum tape here to hold them in position, and we're just going to clamp those in the wire holder in the lathe. Okay, we have the electrodes mounted in the electrode holder, and we're ready to make the pinch. Okay, the first thing we do is we take the tungsten wire and we drive the oxygen out of it. We do that by just heating it to white hot for very short periods of time. Not hot enough to melt the connection off of the electrode, but enough to drive the oxygen out of it and the nitrogen. We don't want any air bubbles to form when we make the pinch. In the manufacture of the tungsten wire, air is trapped in the wire as it's pulled through the drawing die. And by heating it up, that drives that air out of there. Just be careful not to overheat it, or it'll break the weld and ruin the electrode and have to make it over again. Okay, that looks good. To make the pinch, we use the double-sided torch tip, and we'll first warm up the glass a little bit. Preheat it. You don't have to do too much on Pyrex. And we'll go ahead and we'll use the masher tool. I clamp these wires so that I don't hit them with the torch and burn them off. Okay, we now have all the wires clamped in the glass. We haven't made the pinch yet. Right now I'm just getting it mechanically ready. Now I'm going to heat it up and I'm going to do the actual seal, the pinch itself. Okay, that's the pinch. I really squished hard on that to make it clamp down on that glass. Okay, that looks very good. Okay, now we're going to cut this off to the right length so that we can make our flare. Use the diamond saw. Takes it right off of there. Okay, to hold this while we're doing the flare, we use a finger gripper. What it is a piece of tubing that has slots cut in it so that they're flexible, and we can place our tube inside here. We have a piece of spring that fits down over it and that clamps it down. And that holds our piece while we're doing the work on it. This part chucks in the chuck of the lathe. Okay, to make the flare, we're going to go ahead, we're going to heat the tubing, and we're going to use a carbon tool just to pull it out. I put a piece of aluminum tubing over the wires so we don't burn the wires off while we're in the process of doing this. I'm just going to take this carbon tool and I'm going to pull out on it once we get it to molten temperature. We'll check it, see how the size is. Okay, a little bit larger. Oops. That's not good. Okay. Make it a little bit larger there. That's perfect. Okay, that gives us our flare. Now, the flare's a little bit wobbly, so I'm going to go ahead and use a flat carbon tool, and I'm going to go ahead and true it up just by heating it. And that makes it to where it's not wobbly. And that gives us our flare that'll seal to the bottom of the... Okay, we have our seal and our plate. We've made the plate out of a piece of conduit. Took a piece of electrical conduit, 3/4 inch, and machined it to where it's about 10/1000ths of an inch thick wall. Okay, then we took a slitting saw and we cut little slits in the end of it so that when we press it over this piece of glass, we won't tend to break the glass. Because if it's a 1-to-1 fit of steel over glass, it would shatter the glass when temperature hits it. So we put those slits in there to relieve the stress. Okay, our grid we made by taking a piece of spiral wire. We just took a spring and we just took pieces of thin stainless steel wire and we just welded those onto it to keep it into a stiff shape. So that gives us our grid. The next thing we'll do is we'll go ahead and we'll adjust our leads and we'll put our filament in and get that aligned up to where we have it the right length at the right position. Okay, now what I've done is I've bent the leads out of the way for the grid. We'll leave them out of the way for the time being. Then I took the filament leads that go to the power and I've bent a little angle in them so that we can get to them good with the pincher welder. Okay, the support wire, I took and flattened the end of it by hammering it on a hard piece of steel, and then took the diamond saw and cut a little slit in it so that we have a little fork in the end. That way the filament wire will come up, go over through the fork, and back down and be welded on at the bottom. And that'll give us our hairpin filament. Okay, let's go ahead and do the filament. Alright, for doing the filament, we have a little hairpin of 5mm tungsten wire. This was removed from an old vacuum tube. And we will take it and we'll put the top of it in the fork. Okay, and then the bottoms we're going to weld onto the proper places here with the pincher welder. Okay, that's one. Okay. Well, our other one popped off. We're going to run the current up and we're going to hit it a little more current here. Okay. The other one popped off of there. We'll go ahead and do it again. Okay. And we look at these to make sure they're good. Okay. Now that gives us our filament. We have just a little hairpin. Now what I'm going to do is I have to bend these in so that this will sit right in the center of the grid. Okay, the grid, go down here like so. Okay, we're a little bit wide. I'm going to go ahead and I'm going to bend these in so that the filament will not have any tendency to touch the grid at the bottom. All I'm doing is just bending these wires in just a little bit. Not enough to cause them to touch the center support. Now, what that did is it just makes it to where the filament is more parallel instead of being a hairpin shaped. And that way, when we place it up inside of our grid, we'll have no chance whatsoever of it shorting out. Okay, the next thing we do is we're going to bend these 3 grid support wires up to where they're in position and weld the grid into place. I'm just going to grab these wires. I have to hold them very solidly so that I don't put any stress on the glass, and I'm just bending them up vertical. Hopefully in the right position. I can't tell without holding the grid on there. It could be right there. Okay, so we're going to straighten this one out considerably. Next thing we're going to do is we're going to coat the filament with the oxide that is the high emission oxide. I'm just going to pull this filament out here. Okay, that's our filament. Now we're going to coat that wire with the oxide, and that's going to be for our high emission. Now, to put the oxide coating on, we have a mixture of half barium oxide, half strontium oxide, not oxide, but carbonate. We have a propane torch turned very low. We're going to use that to go ahead and cause the oxide to harden. We have the mixture mixed with water to form a slurry. Now I'm just going to take a very small paintbrush, and I'm going to just take a drop of it on the paintbrush, and I'm going to go along the wire. I'm just painting the slurry onto the wire. And I'll just take it and pass it over the flame, just enough to cool it. I don't want to heat it up to the point where it causes it to desiccate, turn into oxide. Otherwise, it'll turn into a hydroxide, which gives trouble when we do pull a vacuum. Kind of a touchy job, but it's really not that difficult to do. We're just going to put it on there about twice the thickness of the wire. We're going to make the wire about twice as thick as it is normally. It's about 5 mils. We're going to put about 5 mil coating on it. That looks pretty good. That's what we're going to use. So we now have the filament coated with oxide. Now, what we're going to do is we're going to put the grid support wires on. We have the grid cage, and we have to adapt from the feed-through wires onto the grid cage, and we're going to do that using a fine piece of nickel wire. We're going to weld those onto the stubs, and that'll provide us a flexible wire that we can adjust the position of very easily. Okay. Okay, I'm going to go ahead and pop the first one on there. Very quick little shot. Well, a little more than quick, but it's going to work. Okay. Second one. That was quick and just right. Okay. Then we have the third one. Okay, the grid is now welded on. Now, we'll just bend these around a little bit here and there just to make it to where it's concentric. Okay, the next thing we're going to do is we have to drill the 2 holes in the glass for the plate and the grid lead. Now, to do this, we use a Dremel tool with a ball mill in it. It's a little diamond ball mill, a burr, I guess they call it, and this cuts through the glass fairly quickly. We run it relatively slow, and we just start grinding in the place where we want it. Gotta have a steady hand. Doesn't hurt the glass. It leaves a little mark on it, but it isn't going to hurt it. The envelope's pretty thick here, it looks like. There we go. Nice little hole. Okay, next we'll do the one for the plate. Now we'll open the holes up a little bit using a cylindrical tool. Now I've got a little pointed tool in here this time. I'm going to go into the hole and I'm just going to open it up to about the right diameter. We just want them to be about 1/8 of an inch, a little less than 1/8 of an inch maybe, and that's it. Okay, those are our two holes where the feed-throughs for the plate and the grid will come through. The next thing is to make the feed-through buttons. We'll take a small piece of glass and we'll make a bead on a piece of tungsten wire that'll be the actual hermetic feed-through. And those will be sealed onto the glass for the actual wire feed-through lead. Okay, what we'll do when we bead it is we're going to go ahead and take a small piece of glass tubing and we're just going to put it on the joint where the tungsten wire is. We have a piece of nickel wire, tungsten wire, and then nickel wire. The tungsten wire forms the actual seal to the Pyrex, and the nickel wire is used for the connections. Now, first thing we do is we'll drive the oxygen and air out of the tungsten just by heating it up to white hot temporarily there for a very short period of time. Just make sure we don't have any bubbles when we do the seal. The bubbles will for sure make a leak. Okay. Now we'll put a piece of Pyrex tubing keep one end of it, get it to seal to the nickel. Okay, now I'm just going to work along with the torch, causing it to collapse down onto the tungsten. And that forms the seal. Okay, and that's our bead. It looks very good. We do the one for the grid lead. First we drive out the air. Whew, almost burned it off. goes onto the nickel. And we do the seal. There's our bead. That looks very good. Now that forms a perfect hermetic seal for the wire going through. And yet it leaves us the Pyrex on the outside to make a really quick and easy seal onto the envelope, so we don't have to do the seal while we're making the connection to the envelope, which would be very difficult to do. Now, we have our tube put together. I've got two getters put on here, which will flash when we get the thing together to keep the gas out of it. Now, here's where we have the problem. We have to be able to get this thing up in here and seal the bottom, but we can't do that when we have the two leads coming off the top for the feed-throughs. So what we're going to have to do is put the tube together in two pieces. First, we'll put the elements inside, and we'll seal the bottom. Then we'll use the diamond saw and we'll cut the envelope in half right in the middle, and that will give us access to the top of the tube to connect the two wires to the plate and the grid and feed them through the feed-throughs. Okay, then we'll go ahead and we'll seal the tube in the middle, and then we'll seal the feed-throughs, and that will give us the completed tube. I mean, it's just one of those places where you got a gotcha in the glass work. Feed-throughs through the side are the worst type of tube to have to make. Okay, I'm going to mount it in a lathe. Okay, we have the tube mounted in the lathe. We used a carbon rod that fits up inside the flare to hold the elements, and then the envelope is held by the evacuation stem in the other. That lets us keep everything in line when we're doing the heating. Now first we're going to go ahead, we'll just heat it up slowly with the annealing torch just to make sure we don't crack it. We shouldn't have any trouble with it. With Pyrex, we don't really have a lot of trouble with cracking, but it's fairly cold in the room today, so we'll take it up to 500 degrees or so until it starts to flare, and that way we'll be sure not to crack it. We have that cold carbon rod in there. You know, that can cause a little bit more stress on it than if it was just plain glass. So we just bring the whole thing, carbon rod and all, up to temperature. Okay, we're flaring good, so we're up to temperature. Now, what I'm going to do, I'm going to heat it up good here so that we don't have it cool off while we're doing it. We've got it aligned perfectly. It's just so close that it's really excellent. Okay, I'm going to take the small carbon, and I'm just going to push the flare up against the envelope as we heat it. Okay, it's fusing. I'm just going to work around. This is why we want that flare in the house and the envelope to be very close to the same diameter, so that when we're doing this sealing together, it all just flows just perfectly. Okay, that's it. Now I'm going to pull the carbon rod out. Okay, now we're going to put pressure using our tube, and we're going to blow the glass out a little bit to even up this base so that it doesn't have a sharp edge to crack. I'm holding my fingers over the holes in the side of the envelope so I can build pressure up. Okay, that looks perfect. Absolutely perfect. Okay, we'll just cool her down a little bit. Next, we're going to use the diamond saw, and we're going to cut the tube off right about in the middle. That'll let us go ahead and fasten the leads onto the plate and the grid. Okay, we've used the diamond saw to cut the tube in half. Now what we have to do, one certain position it goes is like this. We have to fasten the two electrodes onto there so that we can just take them and slip them into position. Okay, we've got the seal for the plate welded onto the plate, and we can just take that and just push it through. And it fits exactly right. Okay, now we have to do the same thing for the grid one. It's just a matter of welding the wire onto the grid and then extending it up to where it'll fit through. Okay, we have the grid wire on there. Now this one I used a piece of real fine spring wire because the grid is not very stiff in there. And if we have any tension pulling, it'll pull that grid out of alignment and cause trouble. So by using that flexible wire, we make it to where it isn't going to affect the alignment of the grid. So we can just take these and put them through. Okay, that's the way it should go. But make sure that grid wire doesn't get down there and touch the plate. That would really be funny. Have it sealed together and shorted out. Okay, next we will seal the tube together around the outside. We have the tube mounted back in the lathe, all aligned to where it's got the seam to where it's more or less together. Now what we used is small pieces of glass Pyrex to go ahead and we'll seal that seam together. First we'll go ahead and use the annealing torch to warm it up. You don't want to crack it at this late of the game. We're very close to having a good tube here. Okay, we've got this pretty well sealed together. All I did was took the torch around there and sealed it. Okay, now I'm going to go ahead and seal the feed-throughs. Alright, it's got the whole envelope hot there. Okay, we're going to do the plate feed through first. All we do is heat the glass up, and we wiggle the feed through to make it contact on all sides. Well, if it'll move, it's got a pretty stiff wire on it. We've got one little place in the back that didn't seal, so I'll use a little piece of Pyrex rod to fill it in. Okay? That's the plate one. Now we'll do the same thing. Now with the grid one we got a little bit easier because we got a spring on it, and that makes it where we can move it around easier. They look real good. Now, if we can cool it off without breaking it, we've got it. Now, once we cool it off, we put it on a vacuum system and we test it for leaks. Okay, now we'll put it vacuum system. Whew! Sucker's hot. Okay, here goes again. Oh, still got a leak. Oh, it's not pumped down yet. Hey, looks good. Got no, whoop, there we go. Uh-oh. Not good. Ah. Yeah, we're not done yet. Got a leak right there. Alright, we got it heated up again. Now we're on the center seam is where we got the leak. I've got it annealed. Now, I'm going to take it right where the mark was and I'm going to just heat it. Okay. There's another place where we got a little crack here. All right, let's try that. All right, we got it pumping down again. Let's see what happens. Oh, not a bit. Okay. Let's see. We're completely sealed. Now, we'll put the oven on it. Alright, we got it pumping down now. We got the oven turned on. And we're sitting at about 25 microns. So I'm going to go ahead and open the main valve. And down she goes. Okay, we'll just let that sit. It'll go on down to 0 there as the diffusion pump heats up. And we'll let it sit for 4 hours. Okay, we've been baking it for 4 hours. I've taken the oven off, cooled it off, and I've connected up the transconductance meter to it. We'll just see how the tube does before we seal it off. If it doesn't work worth a darn, we won't even seal it off. We'll just take it and call it a dud. Alright, let's go ahead and give it some filament. It's lighting up inside there. And we'll give it some plate voltage. Okay, we got transconductance. Okay, at 67 volts, we got a transconductance of about 150. 4 volts filament. Let's go up a little in filament. There's 5 volts. Okay. Let it stabilize a little. Okay, with 5 volts filament, 67 volts, we get 200 transconductance. Let's take her up to 90 volts and see what happens. Okay, we're reading 90 volts plate voltage. 1.5 milliamps plate at 5 volts filament, and we're getting about 280 transconductance. And it's holding very steady, so it looks good. Let's take it up to 6 volts and see what happens. Okay, we see no change, so therefore 5 volts is the filament voltage. Let's take it down a little bit. 4.5. Drops a little bit at 4.5, so between 4.5 and 5 volts will be the proper filament voltage for this tube. Okay, let's go ahead and seal it off. To do that, we use the getter flasher. We have to flash the getters, and then we'll go ahead and seal the tube off. Okay, we have the getter flasher hooked up. It uses a coil. We have a power oscillator driving this coil. Puts out 350 watts of RF. We're just going to hit these getters, heat them up, do this a little bit slow so we don't see it's evolving a whole lot of gas right now when we heat these, and we don't want to overload the diffusion pump and cause the pressure to rise. I'm going to hit the other one. We got 2 getters on this one. I'm just heating them up and watching the pressure gauge to make sure we're not overdoing the vacuum. I'm going to let that sit there for about 5 minutes, and that'll take the gas that's in that tube has got to have time to go down through that stem. That's going to take about 5 minutes, so I'm going to just let it sit for about 5 minutes. Okay, we've let it sit here for 5 minutes. I'm going to go ahead and flash each of the getters. I'm just going to go ahead and heat them up. There they go. All right, now we'll get the other one. Turns red hot, and all of a sudden, the material comes off it. See it just evaporating off of there. That's all it takes. Next, we have to seal the tube off. This is the most critical part of the whole tube making. Goof up here, and it's over. I've had that happen before. Overheat the glass, and the pressure pushes it in and blows a hole in it, and the tube is no good. Look, it's going in. See, it's starting to collapse. Now I'm going to twist it. It's off of there. There's our tube. A Type C round tube. All right, here we have our round tube mounted in a Marconi short-range radio telephone transmitter receiver. And there's our tube right there. The finished round Type C tube used in the receiver section of this Marconi transmitter receiver. Now another one which I didn't make a video of is the Type T. This is the Type T transmitting tube. It's very similar to the Type C, but it's much bigger. It's 3 inches in diameter and about 6 inches tall. And that's what it's used for.